Welcome. For this lesson, you have to download the Dynamics Worksheet 2A, which you'll find in the link on Compass. And there'll be a series of 4 videos of which I will be doing the solutions to question 1, 2, 3, and then 4. So let's begin with question 1. The situation here is we have a series of 2 pulleys which are attached to a 15 kilogram mass down here, and we have 2 masses, X and Y, that have been attached to them, and as a result, the angle here is made 25 and over here is made 45. The entire system becomes static, so we're in static equilibrium. And we're asked to find out what are the masses of X and Y. Right. To do this, we're going to create a force diagram. So let's do a simple force diagram. So we have a force going up there, which is the force of X. Okay. And we have another one going in this direction, and that will be the force of Y. And of course, we have a gravitational weight force going down there. The angles, not to scale, none of this is to scale, it's just a way of getting a force diagram together. That's 25 degrees there, and this is 45 degrees there. Right. Now, once we've drawn our force diagram, we need to resolve each of these forces, Fx and Fy, into their component forces. So doing that, I'll just continue this arrow here, that vector there, and up to there. So this is Fx. So this is Fx cos 25. And this one over here is Fx sine 25. Doing the same with the other side. This is Fy cos 45, and this is Fy sine 45. Right, we know this is in static equilibrium, so the sum of all the forces equals 0. So this means that the vertical forces must sum to 0 and the horizontal forces sum to 0. So the 2 vertical forces, which is those 2 there, must equal that one going down there. So writing a mathematical expression for that one, we have therefore Fy sine 45, that's this one, plus Fx sine 25 must equal mg. So that means that this bob here, this is the 15 kilogram mass, it's not rising and it's not falling. It's neither also going sideways. It's not moving this direction nor that direction. So these 2 forces must also be in balance. So Fx cos 25 must equal Fy sine 40, cos. I should just work that out. Okay. So Fx cos 25 must equal Fy cos 45. Right, now we do know what m is over here, so that is 15. So we can actually use all this information and get a value for mg. So just rewriting them, I'm just going to move up slightly. Got all of our stuff there. So Fy sine 45. Now we do know that sine 45 is 1 on root 2, but I'm just going to leave it as sine 45 for a moment. Plus Fx sine 25 would equal 15 times gravity, so the gravitational acceleration, so 15 times 9.8, and that's 147. Also on the other side here, the other simultaneous equation that we'll be using in a few more moments is that one. I'm just transferring it down there so you can see them side by side. Now we're going to use this equation here and substitute it into here. As I mentioned a few moments ago, this is going to be done by simultaneous equations. So you make the decision which one you would like to get rid of. You can either get rid of fx or fy. Don't forget that cos 25 and cos 45 are just values. So let's get rid of fx because it's on this side. No reason at all why I chose that one. So you could have done the other way. You could have got rid of fy if you'd like. So just making an expression for fx, we've got that. Putting this now over here, you get fy sine 45 plus, now instead of fx, it is fy cos 45 on sine 25 multiplied by, oops, that's not cos, it's not sine, it's cos, let's put that, cos 25 multiplied by sine 25, and that equals 147. Taking out fy as a common factor, we have fy outside of sine 45 plus cos 45 sine 25 over cos 25, and that equals 147. Solving now for fy, so just make, I'm going to help you out there by creating this value in here. So just popping that in, that would be sine 45 plus it's cos 45 times sine 25 over cos 25. Okay. That is 1.036. 8 ... Okay, giving us fy equaling, bring that up again, just running out of room there, 147 divided by that value is 141.8 newtons, rounding there at the end. Okay. Now we know what fy is, we can now use it to, straighten that up, to find fx, because fx is found by this formula up here. So fx would equal 141.8. I'm going to use the exact value for that in a few more moments, times cos 45 on cos 25. I'm going to use the value that's on my calculator for that value there. So that times the fraction, which is cos 45 over cos 25, and that's 110.6 newtons. Right, so we now have values for these two forces here. So Fx is 110 newtons, 110.6 newtons, and Fy is 141.8 newtons. But we don't want to find Fx and Fy. We want to find the mass values of X and Y. So how are we going to do that? Going back down and having a look at the situation, if we have a look at our diagram here, this, the force up here is Fx. It then goes over the pulley, and there is a tensional force here, which is pulling back. The pulley just redirects these two forces, and this tensional force is the same as the Fx. So the force that is being pulled up here is the same as the gravitational force down here for X. So all this tensional force here and this force here, because they are equal and opposite, is equal to the mass times the gravitational force, gravitational acceleration of X. So looking at X, so Fx would equal the mass of X times G. Now we know force X is 110.6, and that would be the mass of X times 9.8, giving us the mass of X being 110.6 divided by 9.8, and it is 11.3 kilograms. Repeating the same thing for Fy. Fy would equal the mass of Y times 9.8, and that's 141.8, equaling the mass of Y times 9.8. The mass of Y, therefore, will be 141.8 divided by 9.8. And that is 14.5 there, kilograms. Okay. So this leaves us with X and Y here, so that X is 11.3 kilos, and this is 14.5 kilograms. Okay. I hope that made sense for you, and I hope that you were successful at doing question 1.